Welcome to a brilliant holiday extravaganza.
Oui, bonjour à notre vitrine de tous les projets de créativité scintillante de notre défi de cette année.
I can't imagine the participation. Actually, I can't imagine because you know what? Ever since September, we have been receiving applications from you to produce, to make something brilliant for our holiday challenge.
Oui, ça fait qu'on a eu plus de 50 classes d'inscrites à notre défi de créativité scintillante et les 3 provinces de la Nouvelle-Écosse, du Nouveau-Brunswick et de Terre-Neuve et Labrador.
Ça là, c'est pas tellement spécial. Like we've been doing a lot of thinking over the last, I don't know, 8 years about what does a brilliant holiday challenge mean? And I think for us, for our culture, for all of our students and our educators, anyone who Brilliant Labs has the opportunity to work with.
Oui, ça fait qu'on a vraiment travaillé cette année à changer puis à apporter que notre défi de créativité scintillante garde ses traditions familiales ou les traditions qu'on a dans le temps des fêtes, mais quand même de le faire d'une façon un petit peu plus durable. Ça fait qu'on va explorer, on a eu la chance d'explorer plein de matériaux avec des élèves d'un peu partout et des matériaux pour faire pousser nos propres décorations de Noël. C'était super intéressant.
It was really interesting. I've learned a whole bunch, and it speaks directly to our family traditions. I remember, it's crazy, but stringing garlands with cranberries and popcorn, and they rot, like they don't stay around, and you are wasting food. And so is there an opportunity created that we can turn that biomass into something else? And our students really knocked it out of the park, whatever that expression is, and they created something truly beautiful.
Oui, on a vraiment eu des belles réflexions avec les élèves. Puis si jamais aujourd'hui ça vous tente, pendant notre vitrine, vous pouvez aller voter pour certaines, si vous avez, pas voté, mais pensez à si ce qu'on partage aujourd'hui comme projet vous fait réfléchir, vous pouvez vous rendre sur brilliantlabs.ca/vote, V-O-T-E. Notre collègue va le mettre dans la discussion du lien YouTube. Et c'est là que vous allez pouvoir interagir avec ce qui se passe derrière nous.
Okay, so this is crazy. What you're saying is that everyone can go vote and actually interact with some of the projects here in real time.
Oui, ça fait qu'on a toutes sortes de projets qui sont allumés, ils sont prêts à recevoir vos informations. Ça fait que si vous vous rendez sur le site, vous pourrez bouger. Peut-être que vous allez tricoter une tuque.
Oh my goodness. So brilliantlabs.ca/VOTE vote.
Yeah.
And I'm not sure if you're actually voting for anything, but there we want you to express, you know. Ah! Oh!
Il y a quelqu'un qui vient de faire exploser des confettis.
Oh my goodness, that was amazing. Okay, why don't you take some time, Natasha, and explain the other interactions, and I will reload. That means that for someone during the holiday season, it's important to laugh, right?
Oui, ça fait que ça, c'est quand on rit, on fait lancer les confettis. On a aussi un qui va arriver, qui va... Oh, ça reçoit un signal, c'est que ça devrait commencer sous peu. Pour tricoter, on a l'autre qui va faire interagir. C'est les... Je l'entends... Ah, les moteurs cerveau.
Look at that! Someone actually just tried to fire it right now. Hey, are you mashing the button over there? 1 second, I got to get it loaded. Okay, here we are. Here we are. We're going to go A. Oh, now I'm going to take the pin out here. So this is a 3D printed, it wasn't our design, but we wanted, so we 3D printed this confetti cannon, and there is a plunger. This was really cute this morning. There are a whole bunch of students here at George Street Middle School getting their projects ready, and we needed confetti. And so this turned into an entrepreneurial service. The girls went all around to 45 different classrooms, and hey, stop pushing it!
Non, mais il y a quelqu'un qui veut voter pour tricoter. Attends un petit
There we
peu.
go.
Donc, si quelqu'un a un beau souvenir, essayez-le de nouveau. Ah, la machine à bloc. Un petit peu. Josh. Attends un petit peu, ça fonctionnait.
Well, there's a lot of technology going on in here, right?
So, let me...
Hey!
Ah, là, il va, là, il va. Woohoo!
Uh-oh. We keep getting spamming here.
Yeah.
People are mashing the buttons. That's awesome. Here, I'm going to actually turn that off. Turn that off. We are going to load the pin.
Bouge ici avec, c'est pour ça. Oh,
using a very fancy paper clip here.
Yeah. But first, avant qu'on continue, Jacob, peut-être qu'on devrait enlever l'éléphant dans la pièce, like the elephant in the room.
That's a good idea.
Let's talk about this
That's
project.
a good idea.
Donc, notre projet qu'on a eu cette année avec des élèves de l'école d'Anthony de Maillet, ils nous ont partagé un éléphant dans la pièce. Ça fait que vous voyez, un éléphant dans la pièce, c'est un message qui est dérangeant, c'est des sujets qui sont un petit peu tabous, dont on ne parle pas toujours. Puis je vais laisser les élèves d'Anthony de Maillet vous présenter un petit peu leur projet. Et là, on peut regarder les messages. Donc, c'est vraiment des choses, des messages qui dérangeaient les élèves, puis ils ont eu la chance de nous partager ce qui était important pour eux. Puis c'est souvent des choses, le temps des fêtes, veut pas, même si on a des belles traditions, parfois il y a des choses qui sont là en famille, qu'on n'ose pas discuter, mais qui prennent de la place. Ça fait que c'était ça, takes a lot of room.
Absolutely. And I remember, my parents using this expression, and we've all grown up with it. The elephant in the room, let's talk about it. And so we turned this into a really interesting...
Ah!
I love it.
Yeah.
I love it. I love it. And so what if we had something physical that took up room, that we were forced to talk about these topics like poverty, like food waste, like socio-political issues, cultural issues that are essential for our community's survival, and rather than sweeping them under the rug or just not talking about them at all and calling it the elephant in the room, let's live within that tension and create a physical object that we have to discuss. And so I really love this analogy. And students, how did they make this?
Cardboard. Ça fait que c'est fait avec du carton recyclé qui allait être jeté à la poubelle. Puis, j'ai trouvé des statistiques intéressantes. Pour chaque morceau de carton, 1 kilo de carton qu'on sauve, on sauve 3 kilos de CO2 qui n'est pas envoyé dans l'air. Ça fait que chaque 1 kilo qui est recyclé, ça fait que tous les cartons que vous voyez ici ont été réutilisés.
On est des élèves de l'école Anthony de Maillet, de la classe de Mme Chantal. L'éléphant dans la pièce comme projet. L'éléphant dans la pièce, c'est des sujets tabous que personne ne veut vraiment parler de. Alors, on a écrit des phrases puis des messages importants dessus un gros éléphant.
Je m'appelle Jacob Hébert de la classe de Mme Chantal à Anthony de Maillet. Puis notre éléphant dans la pièce, on a pris des sujets tabous, puis on a mis un gros éléphant 3D construit avec du carton recyclé. C'est des choses qui comme personne ne veut parler d'eux, mais c'est comme clair que c'est là.
Moi, j'ai vraiment apprécié faire le projet avec les élèves. J'ai beaucoup apprécié la discussion avant que le projet a commencé. Donc, qu'est-ce que ça veut dire un éléphant dans la pièce? Je m'ai mis dans la tête une idée de qu'est-ce que les élèves allaient ressortir, mais ils ont été beaucoup plus loin que mes attentes. J'étais vraiment impressionnée de leur éléphant dans leur pièce, donc leurs phrases qu'ils ont ressorties. Puis, tous les élèves étaient motivés tout au long du projet. Donc, j'ai adoré.
La machine à tricoter, elle veut y aller, puis regarde.
Perhaps we need some technical assistance here.
Yeah.
Our automatic knitting machine, and when it works, this is the magic of TV, right? When it works, you can actually knit by mashing a button, right?
What?
The cloud and all of this is made. Oh,
but
sorry.
First, let's just get this out of the room.
Sorry. Okay. But I thought this was supposed to be an immovable object.
It is, but for today's purpose,
this is beautiful.
We want to be able to see the different projects.
All right, excellent.
Woo.
And off camera here, there we are. Right, I can't load that anyway. Sorry.
Ah, faut toujours tu le load.
C'est ça. Donc, la prochaine fois, on va itérer. We're going to iterate on our design such that perhaps the student could build a reloading mechanism for the confetti cannon.
Mm-hmm. Somebody's trying to knit. It's okay.
So this would actually knit a toque.
Oui.
I think the geometry here is absolutely inspiring. So it's a knitting machine with a TT motor hooked up to it.
See? And I don't know if it's...
That seems to be the solution for everything around here.
IT is telling us to turning it on.
Come on.
Non, on va attendre une petite seconde.
Okay.
Puis vous êtes pas mal beau, Monsieur Lingley.
Well, thank you very much. I know. So we wanted to really explore wearable technology, right? So also known as electronic textiles. Now, I have to tell you, my wires that I soldered here, they came out. So I took a student's project and I just threw it around the back of my neck. So I apologize, camera, but you know, certain things happen. And we're seeing students begin to integrate electronic textiles in a really inspiring way. Like, what if our clothing was actually able to express data from our environment around us?
Oui, c'est super intéressant. Moi, j'ai mis un petit peu d'électronique, donc une microbit avec des lumières codées dans mon vêtement, mais ma jupe a été créée par des élèves de l'école du centre d'apprentissage du Haut-Madawaska, des élèves de 6e année.
Wow.
Donc, ils ont créé mon habit from scratch, ça fait que de zéro. Et ils ont vraiment tout fait. Là. Je les ai donné des idées de ce que j'aimais, mes mesures, elles m'ont mesuré.
Wow.
Les flocons sont faits au découpe laser, parce que c'est du feutre qu'on peut découper au laser. Ils ont ajouté des plumes pour mettre un petit peu plus de volume, mais super intéressant.
That's beautiful. So students made this, you said, from the ground up. Like, I would love to see their design thinking process. They likely started with sketches, and they clearly chose materials that were important to them. Perhaps the texture resonated with them, or that's amazing.
Oh, but you know what? They chose materials that they had accessible.
Gotcha.
They had already. So, c'est tous des tissus puis des choses qu'ils avaient déjà qui étaient réutilisées. Ils n'ont pas rien acheté de neuf.
Right. And so in putting together this challenge, you know, there are a lot of themes going on here. But one of those themes is durability, sustainability. How can we be a little bit more conscious about the materials that we are using? And so for students to look around their learning environments, how are we doing?
I don't know. I was working perfectly fine.
Oh.
I knitted a whole hat.
I know you did.
It's okay.
Well,
All right.
it's trying.
Ouais, it's trying.
It's trying. Thank you, Mr. Keys.
Merci.
Shout out to our innovation engineer. Sustainability. All right. So, what do we have going on here? It looks like we've got a bunch of cardboard.
Oui. Donc, moi, j'ai ma chaise qui a été faite par Nicolas, un élève de l'école Antonine Maillet. Mais le design a été fait par Hailey et Calista et Anna, qui faisaient partie du groupe également, qui nous ont vraiment aidés à construire une chaise en carton. Ça fait que 100% carton.
Okay, now I'm a little fearful for you because I see wires running from it, but that's okay.
That's okay. That's for another thing.
That's okay.
Let's see.
All right, all right.
Et voilà.
Wow. You know, it's interesting because we have this perception about cardboard being fragile. And cardboard has been a really popular maker material in many classrooms. And we have a cardboard connection now that we're super proud of. And all of this set was made of cardboard. And the beauty of this cardboard is it has been recycled and will continue to be reused and recycled. The same thing with your chair. And as you can see, it is not fragile unless you're really supporting yourself here.
Non, c'est correct. Regarde, je peux bouger un petit peu.
Do you notice how I'm not sitting down?
Ouais,
I'm just allowing you to sit down.
Jacob et sa chaise a un style différent parce qu'elle est vide à l'intérieur. La mienne est comme... ça fait vraiment solide, le carton sur le côté, les épaisseurs. Vous avez essayé un différent design, mais Jacob, quand il s'assied dessus, il faut vraiment qu'il travaille un peu comme son corps.
Should I do it? Should I do it? All right. Should I just go for it?
Il faudrait peut-être loader le confetti au cas où c'est drôle, puis il y a des gens qui veulent rire.
Okay. All right. Here we go. 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 Oh!
Celle-là n'a pas fonctionné, mais c'est correct. Moi, je peux rester assis.
Perhaps we should go back to the drawing board there.
Yeah.
So this was a prototypical design. One of the designers is actually laughing right now. So perhaps the next prototype could have a little bit more support. There we go. There we have it, the chairs.
La mienne est encore là.
Careful, I see an angle of your chair there. You may go over, but the chair falling over, it has you got a great opportunity to see a couple of the projects there.
Oui, on a différents projets en arrière. On a dans cet arbre de Noël là, juste vous présenter un petit peu les projets qu'on a ici. Donc ça c'est un projet de Céline qui était à l'école Antonine Maillet. On a fait avec les autres élèves de l'école on a fait pousser du cuir de kombucha à base de SCOBY.
No way.
Ça fait qu'on a fait pousser notre propre cuir, puis on les a découpés au laser. Ils ont également fait des ornements en papier de champignons. Ça fait que c'est du papier recyclé à base de champignons, puis ils ont réussi à faire différents ornements. Et puis Céline a ajouté différents sons dedans. Et que là, pourquoi ça ne fonctionne pas?
Sorry, I just walked away
Mon
because
ordinateur est tombé en veille, ce ne sera pas long. Ça a été en veille, donc ça ne marche pas.
Oh.
Yeah, it's okay.
I just walked away because I wanted to grab some of the kombucha leather that we recently harvested. These students here, they made some of these ornaments out of kombucha leather that they grew. And so once again, under the theme of sustainability, how can we really dig into biofabrication? Is there a way that we could actually make our own materials from nothing more than amino acids, biological structures? And this created kombucha. We allowed it to ferment, and it forms a film over top of it that you can then harvest. And it's very similar to leather, both in color and consistency. It is super strong. There you go.
Et on a réussi à le faire fonctionner. Donc, c'est là, avec son arbre interactif. Et là.
Cool. Okay, how about we do this? Okay, now make sure that we, yeah, can we do this? Okay.
Et voilà, regarde.
Very cool.
Super.
Very cool.
Puis là, on a des élèves qui nous ont fait une guirlande avec du maïs soufflé.
And talking about garlands, actually over here, all kinds of things to show off. This was really cool. I had never done this before, and I'm going to try to do it with my kids. So this is salt dough, and it's just a very coarse mixture of flour and salt and a little bit of water to act as a binding agent. And some of the paint, this one right here, get this, it's naturally dyed with beet juice.
Super.
Pretty cool, huh?
Oui. On a aussi un autre projet ici qui dansait dans les petits patineurs patinaient, un autre projet qu'on avait d'Anna. Puis là, on l'avait placé avec le nuage, puis je sais pas, on sait pas qu'est-ce qui se passe.
So we're waiting for the cloud to
Yeah.
pick up. But you know what? This is pretty cool because the shelves here are blinking. That means that some of you listeners out there are mashing the arcade buttons and making this work.
Ah, c'est vrai.
Right?
Oh, somebody just tried
Oh,
again.
there we are. There we are.
We're receiving the message. And it wants to.
And the confetti cannon will have to reload. Over on the mantle, there are some that are pretty neat. So this one, you can't see any of the mechanics, but this is all done as cardboard automata or automata. I'm not sure which pronunciation is the right one. But we have NeoPixels here, and we can turn them on and turn them off with the B-board. And I'm just going to do this manually. Look at this. So we have a cam and a shaft mechanism.
Okay. Can you pick it up? Yeah.
And just put it on top of the counter there. So here we are with Molly and Isabel. You girls, I recognize you've been down here a lot working on this beautiful project. Can you tell us about it?
Yeah, so basically we're not that good at tech stuff. So
Okay.
we tried to limit that type stuff, and we tried to do more physical stuff that you can do yourself.
Yeah. Well, we started with an idea of doing a ski hill, but that got way too complicated. So we decided to do a skating rink.
Because when you think of Christmas, you think outdoor skating rink, snowman, Christmas tree, and everything like that.
I think that's incredible, and I actually remember one of my favorite parts of this project is walking in and talking to you girls as you're completely stumped as to where to go with this penguin kind of going down an incline, right?
Yeah.
And it was a moment where, teachers, as we discussed design thinking and prototyping and that value of kind of trying to map out the creative process, you girls did an incredible job at just pausing. Like, okay, what is it that we actually want to accomplish? And sometimes it's that idea process is a complete failure as you abandon one idea and go to another one, right? Did it feel like a failure, or you know?
No,
We
I
didn't
think
really
it's
start anything yet.
So why don't you show us what it can do, and then we'll turn around and look at the mechanism a little bit.
Sounds good. Okay.
so once you turn these rods on the side, if the snowmen are on the tracks, they should move up and down.
Yeah. But it's
Just like
really
that.
easy for them to fall off the tracks. So if we had more time, it would be like better, but they're pretty good.
So
right
they don't move by themselves, but whenever you want them to move, then you can just turn these levers on the side.
Why don't we turn it around so that the camera can see what's going on there? Ooh, nice. That's crazy. I gotta take a look. Oh, wow. So I've seen this project before, this type of project before. It's this similar type of gear mechanism can be found in cars, in toasters, like anything that needs to move. Really what you've created is a kinetic sculpture. And so there's all kinds of different cams and shafts that can link together in order to move the pieces. I think that's really cool. If you were to summarize this, here's a tough question. What types of subjects, or just knowledge in general, did you have to use to build this?
Well, we had to use a lot of math and measuring to see where exactly the rods should go and how big those little circles in it need to be to catch circle on top.
And I don't know, we had to do coding.
Yeah.
So
Yeah.
Is that
which
science?
Science.
But that's the beauty of coding, right? It falls into, that's just
Yeah.
what you had to do to
Yeah.
get your project done. No, that's super cool. And so the B board here, you push A and B, and it turns them on and off, right?
yeah.
Awesome. Molly, Isabel, thank you so much for being a part of our brilliant holiday experience, and have a good holiday season.
Thank
Thank
you.
you.
Okay, you're welcome. Pretty neat. Over here, B board, and it says press A. Let's press A. Oh, there we are. We have some light changes. Okay, cool. Clap. I wonder if the B board's on.
Let's see. No.
No? Okay.
OK. Là.
Neat.
Qu'est-ce que ça fait si tu claps?
I don't know. I think this might have been one that played music. I'm just tapping the microphone. Clap. Okay. All right. Perfect. Ashlyn, Misha, you've been down here for what seems like an eternity working on this incredibly brilliant tree. Do you mind telling us a little bit about what it does? First, how did you decide in this makerspace with all you had for an idea was create something that says holidays to you, right? How did you come up with this project?
I guess we just liked Christmas trees and we wanted to make something pretty.
Yeah, and we didn't really know what else to do, but
And we've worked with like the LEDs before, so we knew how to use them. So we just wanted to do something like that.
Cool. So you had already used the NeoPixels before.
Yeah.
It was awesome working with your group, because I think it was the first time where I was able to ask a group of students, do you already know how to use the NeoPixels and B-board? And you're all good. You're like, yep, let's go. Let's jump right into it. Awesome. So why don't you show us what it can do? That's awesome.
Yeah, so when you turn it on, once you make like a sound, like so if someone was like talking or like they decided to clap, it lights up and sings "We wish you a Merry Christmas."
Very cool. Sorry, Misha, I cut you off. What were you going to say?
I was just saying thanks to Merry Christmas.
That's okay. So I have two questions. First, how is it that you were able to get all of these measurements and these cuts? And I know that it may seem simple, like just taking a piece, you're cutting a tree, but this is crazy exact. It's all lining up. How did you do that?
We used the ruler.
nice. So you started out with a rectangular piece of cardboard. But how did you decide how tall the tree was going to be and where to create the branches?
Well, we didn't want it to be super big because we didn't want like the nail pixels to look really small.
Right.
And then we just decided that 4 like branches would be a good size.
Awesome. Misha, were you going to say something? No? Okay. The music. I bet your code was crazy long with all those notes. Did you write that? So you must have the ear for music, or do you play an instrument?
Well, we had like a code to like copy off, so we just kind of like copied the code that was already like done.
Okay.
Like if it sounded right to us, we just left it.
Okay, cool. Well, I think that's great. Do you want to spin the tree around so that we can see the b-board? Awesome. And it's still going the entire song.
Yeah.
That's great. Oh my goodness, Misha and Isabel? Ashlyn. Misha and do we have enough pause there?
There you go. Now go.
Misha and Ashlyn, thank you so much for taking all of this time and making this really cool tree. I hope that you continue to use the b-board, and I think you're going to maybe use it to explore some robotics in the near future. All right, have a happy holiday season. We have a tree down here. Turn the tree around, turn on the b-board, and then clap. Okay, turn the tree around. Here we are. Okay, turn on the b-board. Okay, so our pins are hooked. No way! That's awesome. Very cute.
Puis là, on a le Père Noël ici. On peut enlever le pas touché, je crois, qu'on peut l'allumer.
Oh yeah, and this one has a clipboard integrated into it.
Oui, c'est un détecteur de mouvement.
Okay.
Oh, le mouvement est...
Uh-oh, maybe. Oh! Look at that! I love how the beard, the polyfill from the pillows, Santa's beard is diffusing the light. That is awesome. Now we're here with yet another group of students that I recognize. Brooke and Brianna, you've been working on Mr. Ho Ho Ho, Santa Claus himself. What can you tell us about your project?
Well, it was a tough process to make because we didn't really have an idea at the beginning. We just kind of thought it would be cool if someone was waving and maybe even said ho ho ho, but we couldn't really figure out how to do that in the amount of time we had.
So we put a sensor in it to make it even more just cool, and so that someone walks by it, it'll start moving.
That's so awesome. In your introduction here, as you were describing it, I wanted to zoom in on how you made a decision to just go for this. What inspired you to land on Santa waving?
I think it was just like a general idea because in our tech class, for our tech project, we're going to do a butterfly that moves its wings. So it was a similar idea, except make it a Christmassy theme, and we haven't seen anyone making Santa, so we decided to make it a Santa.
I think that's really cool. How you had already been working with the servo to make butterfly in your technology project, integrate that into Santa using similar codes. I think that's great. Like we do that all the time. Capitalize on past projects and how do you twist it into a certain theme. All right. The other awesome thing is how you use all the beard. Tell me about how it's shining through and stuff like that.
Well, we actually we taped LEDs down, and then we just hot glued a bunch of cotton on top of it, and then just put the LEDs through the cardboard to make it look like it's shining through the beard.
What was your reaction when you first saw the light come through the beard?
It was a pretty awesome thing to see because a lot of the time we always get really frustrated with stuff like this. So once it finally ended up working, it was really cool to see it come to life.
Right? I don't think I will ever get tired of seeing some NeoPixels light up. But what you're able to do here and how realistic it is to diffuse the lights using the polyfill, I think that's great. And all of these materials, they were just lying around the makerspace. So it was super important to us that you didn't get any new materials, that we reused the olds. If you had this time again, any ideas on what you would make the next time around?
Not really. This was kind of just like an instant idea, like
Right.
Christmas,
Yeah.
servos and stuff like that.
Cool.
It just came straight to mind. Probably something similar, maybe not with servos, just
Right.
to make it a little different, but using a lot of more technology that we haven't used yet.
Nice. Well, you've got the clipboard, you've got NeoPixels, you've got a servo, you've got a B-board. Brooke, Brianna, thank you so much for telling us a little bit about Santa. Have a great holiday season.
You too.
All right, thanks.
So, what is your project that you've made for the holiday showcase?
This is a radio, so when you clap, it will light up just in the background here, and it will play Silent Night. But
Okay, let's see it.
stop it. There's
That's
a button.
awesome. So, what materials did you use to make your project?
A lot of cardboard. We had a B-board, a light strip, and obviously a microbit. Some red tape. Yeah. And some of the little cupcake liner things.
That's so cool. And why did you want to use cardboard? What was your inspiration for that?
There was a lot of it flying around, and it seemed like it'd be the easiest to make into a box shape.
Okay, cool. And do you think that you would ever use the B-board again for a project?
Yeah.
And what kind of project do you think you'd make with it next time?
We're making one in another class right now where it's a little coffin that rolls around and yells at people.
Oh, that's so cool.
All right, Gavin, how are you?
Good, you?
Very well, thank you, sir. I understand you've been working on a bit of a robotic project.
Yes.
This has been a long time in the works. Can you take us through a bit of your process here? What have you done?
Well, we've 3D printed most of the skull. We're waiting to print these two. And we just put it together. It took a long time to put it together.
Okay, so each of those parts are 3D printed.
Yeah.
How do they come off the printer? And then what does it take to go from printer to being included in the robot?
Well, we take it off the printer, and man, I don't know.
No. So think about the tools that you're using, right?
Oh,
so
we're using.
So to start again, we take it off the printer.
We take it off the printer, and we use the drill to drill the threads through it. Thread through all the holes, and then we screw it through with I think they're MP320.
The metric screws.
Yeah,
Yeah.
and then all the tools we scrape it off. All the access stuff that we don't need, we scrape the edges right here and all that stuff.
Cool. So this was designed a number of years ago, and so I think it's important to say that we are not the designers of this.
No.
But it takes a lot of effort to even put the puzzle of it together and to get all of the parts ready to assemble. Okay, so you've been looking at this long enough. What do you think an application of this humanoid robot could be when it's done? Even just the head.
The head? Well, we're hoping by the end of Christmas, or when we come back, the head will be done and moving.
left and right and up and down, hopefully. Yeah.
Cool. And what could it be used for in everyday life?
Helping you around the house, maybe. Talking to you. Just keeping you company, maybe.
That'd be pretty cool.
Yeah, it would be.
Right? Well, Gavin, thank you for all of your work that you've done on this project, and we can't wait to see how it ends up.
So, my partner and I, Oliver, decided to make kind of a small area from, if you guys have seen Home Alone, you know how Kevin McAllister, to protect himself from the robbers who are about to attack, he creates this thing that's basically a silhouette. So he makes little, like, huge figurines that look life-size, and he brings them along in a spiral to make it look like there's people in the house, so the robbers won't come. What I did was, my partner and I did, was basically make a scaled-down version of this using cardboard and a B-board. So the main function of this, I would say it probably took more time to build the pretty simple, admittedly, house than it did to code or to put everything together. So if I am afraid it does not work as well as it should, it's basically what I tried to make is a spiral, or a pulley, sorry, that brings a little guy, if you see right here, brings him around the track. And when we were starting to do this, I had a pretty good idea of what I wanted, and this ultimately, even though it doesn't work, is pretty much what I envisioned it as. And what was really fun to work on was that I had all these ideas in my head of what a pulley would be, but with the help of Mr. Keys, he actually told me what those words.
Woo!
There you go. That's a great shot.
That's an outro.
And the nice thing about this place is they'd never even sweep the floors.
No, this will be here next holiday season.
Maker Fair,
Right?
we already have stuff ready for it.
Yeah, exactly.
All right.
Okay, I think with that, we should go to Nova Scotia.
Bonne idée.
Right?
Allez voir qu'est-ce qui se passe en Nouvelle-Écosse avec les projets.
A lot of great projects over there.
Avec Madame, c'est dans la classe de Madame Stéphanie Bellefontaine.
I think we need another little snow.
A little bit of snow.
Good day, everybody. I'm Avery, reporting to you live from the High Fivers room in Smoky Drive Elementary. Quite some time ago, Brilliant Labs came out with a Santa's Workshop project for schools and classes, and the High Fivers took it to the next level. Let's head inside and see what they did.
Welcome to Santa's Workshop!
I wanted to make a piano lesson, and it was hard. I tried a couple of other ways, but I couldn't do it. So I asked Nick to collaborate. I said yes, I would happily help, and I had an idea of how to make a candy machine because I've made something like one before, and this is what we made. Strand. Candy.
I learned a new skill to use squares from the Make-Do kit to screw the whole house together. They're the blue things right there.
So this is me and my piano. I use copper tape and alligator clips to make the music working, and I programmed NeoPixels for the lights. I programmed it to make like polyspell frost. And now I'm the NeoPixel guy in our class, so whenever we have a project that involves NeoPixels, people come to me and ask me how to do the NeoPixels, and I show them that I went through a tutorial how to do it, and then I took a JavaScript from a document that one of my classmates shared, and then I put the JavaScript into it and transferred it to Box, and then it was all again.
And how do you feel about yourself in this project?
I feel pretty good. I learned how to play the piano this year, so yeah, it's pretty fun.
We made toy reindeers to show what we learned about wheels and axles. We used roller beads to make the toy reindeer.
We made a conveyor belt to show understanding of simple machines. We worked really well together. The conveyor belt took a long time and it took some critical thinking to figure all this out.
We thought we didn't have enough structure to move, but it was proud of what we did.
All right. I wonder where Jacob is.
Hey.
Oh.
I hear there's a bunch of great projects in Newfoundland. Should we go?
Well, allons voir à Terre-Neuve. Qu'est-ce qui se passe?
See ya.
Hi, my name is Ashton. I'm from Miss Pretty's class at H&MA. During this thing, I learned so many things. I learned how to code with the keyboard, ended up learning how to code multiple for the keyboard. NeoPixels, I learned how to code music for the keyboard. And that song I got to choose, it was Wish You a Merry Christmas. I have a slight problem with this, meaning not being able to play the lights and the song at the same time, so I went back and tested the issue of the power source, and I ended up lowering the brightness of the lights so then the power would be less directed to that only, and it ended up working fine afterwards. 2, 1, start.
All right, can you explain your project for the Holiday Innovation Challenge?
We are sewing hats and like decorating them with lights and all that stuff. As you can see, mine is stylish, the best one here.
So this is the house that I made. So for like this part right here, the chimney, I just took like a cylinder, raised it up, and then put like a circle in the middle so it can be a chimney. And then I have the half circles right here as bushes, and then I have a little square that I just flattened and made. I made it longer and flattened it, and for a step. And then I have the door and the 2 windows. I have a skylight right here, and then the whole house is just one big box. And I didn't do like a triangle roof. It's like it's a circle, and I really like the house that I made.
Hi, we are students here in Newtown, and we are in my name's Sanford's class.
Hi, my name is Natalie.
My name is Peyton.
My name's Claire.
And my name's Aaliyah. And my name's Lila.
We are currently
We are currently doing an innovation project that the grade 6 students are doing.
And we are building a candy cane factory. We're using Tinkercad for the house. And we made some candy canes out of clay and put some glitter glue to make it sparkle.
What I did for the Brilliant Labs Holiday Challenge was I was going to sew sewable LEDs into a little hat with little Christmas lights on them. So what I did was the hat already had lights in it. They were basically just fairy lights, so we had to kind of dissect the hat to take them out because it didn't work. So we took them out and we put the sewable LEDs together, and we put them in. Instead of sewing the sewable LEDs in, we decided to use Velcro because it was a lot easier. Now we're having some issues with the hat because we use a mixture of stainless steel thread and wires, but it's not working right now because we can't get the stainless steel thread untangled. If it tangles, the electricity won't go to the lights and for now. But still kind of cute though.
For our hat, what we done was we took the wires in the circle LED lights and then we connected those. And then once we had enough connected, we took it around the hat and we put it in. And in our hat, we got a bunch of wires and then a battery pack. It goes all around. And then we got different colored ones, and I'll try to show you what they are. How you won't be able to see it though. So, it's on. Right here we got a red, yellow, and green one.
Yeah, I learned a pretty similar thing saying that if the first tangled, it will not work. And if you put positive to negative, nothing will happen. I learned that a lot. My partner making this, what my friend Lacey showed me, was the first thing that you should do if it's not working, and your threads all spread, whatever you're using is all spread out, look at the battery, because the battery may be dead. But I learned a lot. Turn mine on, light. Okay, that's really fun.
It's like he's saying, ho, 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 or he's telling a secret. That's awesome.
Là,
Okay.
c'est un petit peu, il y en a un autre ici. On a un nouveau là qui dit de peser le bouton A et le B, et
Yes.
je crois que ça change les lumières de couleur, mais je vois qu'ils n'ont pas de lumière, ils n'ont pas de batterie dedans.
Quoi? Oh, on a besoin d'un B-board or a power
Ouais, ils ont oublié
supply?
de mettre les batteries.
Okay. Okay.
On va trouver ça. Et là, si je pèse le A
Ben voilà.
et le B, et les lumières changent de couleur.
And to say,
Ils ont fait ça en 3D, hein?
Oui, c'est ça. And I remember talking to these students, and I asked them, do you mind if we use your project as an example? There was a whole bunch of math that they had to do and some really neat calculations because you're dealing with negative space when we are designing for 3D printing as well as positive space. Positive volume. Did you just roll your eyes
No.
at all of the math? Okay, stay with me here, okay? But also, there's this narrative of sustainability. Where are any of our 3D prints going to be in 5 years, 6
Ouais.
months, 20 years? While this filament is made out of a corn-based bioplastic, it will not degrade for hundreds of years. And so, we challenge all of our 3D printing aficionados, those of you who are interested, into really being mindful of where is your creation, your construction going to be? Is it for now? Is it for later?
Oui, ça m'apporte à vraiment. J'ai des élèves qui ont vraiment eu cette réflexion-là à l'école Antoine Maillet parce qu'ils parlaient, eux autres, d'avoir des traditions familiales. Ça fait qu'ils ont dit oui, c'est bien tout ce qui est durable. Ouh! Père Noël s'en vient.
What's going on?
Donc, c'est bien tout ce qui est durable puis d'avoir des matériaux biodégradables, mais si on veut avoir quelque chose qui reste dans la famille. Donc, je vais laisser Anna et Calista vous en parler dans la petite vidéo. Mais elle, c'était vraiment spécial qu'est-ce qu'ils ont choisi de faire parce qu'elle voulait vraiment avoir que ça reste pour toujours, d'avoir quelque chose qui va rester d'année en année, qu'ils pourront donner à leurs enfants ou à leur famille. C'est que c'était pour ça qu'ils ont choisi le plastique. Mais avoir cette réflexion-là, c'est important. J'ai trouvé ça super intéressant comme réflexion.
Yeah, absolutely. And particularly in a world of, non-fungible tokens, this idea of creating virtual artifacts that are artwork and they may stay around, for X number of years.
Ouais.
And yeah, isn't it? What is that?
Let's see.
Is his mouth going up and down?
Supposed to, I think. Mais elle est supposée, mais elle est toute collée avec plein de colle chaude. Elle ne bouge pas très bien.
OK.
On a un autre traîneau ici qui a été fait par d'autres élèves. Je cherche la manette. Je ne sais plus où on a mis la manette. Aussitôt que je trouve la manette, on va le faire jouer.
This one, the
Yeah.
remote?
Yeah, I lost it.
Oh no!
Somewhere in here.
All right, well, you take a look around. I'm going to try this one out. Okay, so once again, this is a 3D printed and designed snowman. To start, press A and then B. Lightly turn the snowman on if it does not turn on its own. All right, so you know what? Why don't we just bring this right down off of this beautifully constructed shelf. Here we are. Okay, we've got power, and we're going to push A, and then B.
Ah, il est beau!
So, you know what's super cool? We could talk about so many different things about this, you know, opportunities in which the students have learned and really thought about their thinking and design. But the music, they had to write that note by note.
Mm-hmm.
Okay, so it's a completely different music writing process. They're dragging out blocks and then selecting the notes, but all of that was written from scratch, you know, using code.
Oui, ça fait que des fois, c'est des projets qui semblent, tu sais, les jeunes doivent vraiment y réfléchir. Comme je regarde celui-ci qui a été fait par Anna, il fallait vraiment qu'ils mesurent les angles des personnages quand ils allaient bouger sur la patinoire. Puis, tu sais, avoir toute l'idée, elle avait beaucoup. Je vais la laisser en parler un petit peu, là. Je vais laisser mon collègue en parler. Puis là, après ça, elle allait bien aimer décorer les maisons parce que ce papier-là était découpé avec la découpeuse laser. Puis c'était vraiment une force. Tu sais, quand on parle de mathématiques, il y avait toute cette construction-là également à être faite. C'est super intéressant.
This is screaming geometry, right? Because of the servos, each one of these, as it receives code, it has to spin at to a specific angle and then go to a specific. The houses are a beautiful net when they are cut in the laser cutter and then folding it up, choosing the type of glue that you use to adhere it together. This reminds me, the skating, isn't it cool how we had, oh my goodness.
Oui, ça a tout atterri dessus.
It was moving. And then we also had some confetti falling like snow, right? We could do it like this. But this reminds me, growing up, I was always fascinated with the skating figurines that moved on a pond. Is that what this is?
Yeah, kind of.
Okay.
Oui, puis on a essayé avec des aimants, mais c'était difficile. C'est ce qu'elle voulait faire avec des aimants pour les faire bouger avec la polarité, mais le carton était épais. Ça fait que ce qu'on avait comme matériel, on ne voulait pas acheter plein de matériel, on voulait vraiment réutiliser des choses qu'on avait. Ça fait que c'est pour ça qu'on n'a pas pu les faire bouger plus qu'il faut avec les aimants.
Gotcha. So the magnetic field, the cardboard was too thick. It wasn't. Okay.
The magnetism of the thickness of the cardboard was the issue here.
Right. Very cool. Okay, gentlemen, how are we doing? Okay, thumbs up. On a une pièce de résistance pour la fin de slide.
I don't know. I didn't find the remote. Tell me, I lost it. J'ai vraiment perdu le remote dans tous les projets. Je l'avais au début.
Let me check over.
Il y a des cordes qui passent à travers des poulies. Puis là, ça fait que ça va glisser dans la corde en transportant le crayon avec.
Une corde transparente.
Nos rennes, on a trouvé les rennes originales au Dollarama. Puis là, on les a toutes peinturées à la main parce qu'ils sont clairs originalement. Puis là, on a ajouté des harnais avec des cloches qui étaient aussi trouvées au Dollarama. Puis des différents fils de métal que mon père m'avait donné.
C'est recyclable aussi.
C'est recyclable.
Puis ces petits rennes-là, ça va être donné de tradition en tradition comme ornement de Noël. Puis nous autres, on va les transmettre à nos enfants qui vont les transmettre à leurs enfants. Puis ainsi de suite.
Quel est ton nom? Et en quelle année? Qu'est-ce que tu nous présentes aujourd'hui? Qu'est-ce que c'est?
Une maison.
Maison. Comment, elle est faite comment, votre maison?
Avec du carton, du papier, de la ouate.
Excellent.
Des collants, des bonbons, des lunettes.
Oui, je vois ça flasher. Ça, c'est la maison que vous avez faite après avoir lu quel livre?
Hansel et Gretel.
Puis, c'est la maison à qui dans Hansel et Gretel?
À la sorcière.
je l'ai trouvé. Je l'ai.
Tu l'as.
Mais je quoi?
Oui, ça se peut. On va regarder s'il va avancer. Donc, c'est un traîneau que Samuel et Jacob ont fait. Puis ce traîneau-là, il est vraiment tout découpé au laser. Samuel a fait le design. Puis il a fait étage par étage, comme on avait vu des fois avec certains, avec certains logiciels pour travailler le carton. Et si je me souviens bien... Ah! Il recule. Et là,
oh, it's a little
j'ai oublié
tippy.
qu'il reculait. C'est un peu... On va le refaire ici. Watch out, Jacob.
OK. Oh, wow, that's awesome!
Avec le Père Noël s'en va. Ouh! Ça, il a arrêté juste à temps. Super! Donc, ils communiquent, les microbits qu'on a ici, ils peuvent communiquer avec un message radio. Ça, c'est toute une autre pensée computationnelle parce qu'ils doivent être capables de programmer la manette, mais aussi programmer le B-board et l'autre microbit pour le recevoir le message.
Yeah, there's a lot of wireless signals going
Oui.
back and forth. I
Oui.
feel them, in my brain. Just joking. So we have some snowflakes over here, same kind of thing. They were cut on the laser cutter, and I do the math guy, the math teacher in me loves snowflakes because they are a fractal representation of geometry designed by students. Anyway, I believe I'm not really tall enough to retrieve this and turn it on, but I'm going to try. I always risk. Oh, it's on the other side. Okay, here we are. Turning around. Hello, tree. And we are...
Ils ont vraiment mis la musique en boucle, hein? Ça fait que la musique, elle est toujours continuelle.
There. Hey! Very cool. And look at that, snowflakes turning, we have our snowmen turning, snow people turning. Aww. So one of the things that we haven't discussed is that this entire set was built by students with cardboard and using make-do screws. We were really conscious this time around as to the type of adhesive and the amount of adhesive that we used. All of this was made from cardboards and held up by make-do screws. And so a big shout out to all of the students who helped with the design and the cutting and the creation of this set over the last 3 weeks.
Oui, puis on a encore beaucoup d'élèves qui sont en classe, en train de travailler sur leurs projets. Ça fait qu'on a vraiment hâte de voir tout ce que vos projets que vous allez pouvoir nous envoyer. Ça fait que on attend. Vous pouvez nous envoyer ça à info@brilliantlabs.ca, mais aussi vous pouvez nous les placer sur les réseaux en mettant le mot-clic Créativité Scintillante ou Brilliant Holiday en anglais.
Yeah.
There's still time to showcase your projects.
Absolutely. I think we've done a great tour of the projects. There's much more to come. Please check back on Friday, brilliantlabs.ca. Follow us on Twitter. Now we're going to get to work to put everything together and show off a few more details.
Yeah. Ben, merci beaucoup d'être joint à nous, puis passez une belle journée.
Thank you very much.